Hi my friends, today we model this part, elastic handle, which can be used for indexing. Grab your hand from here and bend the elastic part. This is the elastic part, and then rotate the handle and switch it with the indexer. This is the indexer in the next position. Such a situation can be this one. This is the part 90. You can find it in our tutorial. And grab the elastic part of the handle, this part, and then move to the next position, like this one, yes, or the other one. Use these channels to fix the position. The drawing is this one. You can take care with this note. Elliptical sections are associated with the levels at which they are found. This profile or section correspond to this position, the next to 55, this one to 131, as well as the left one, and the last is at position 38. For the front, this is the ellipse to be used. The part is here, and you can see the indexer and the model. Okay, then we can start. Yes, we start by creating a first sketch in the plane XY, which is the directory for a loft operation. We draw a short line of 17 up, then an arc, a line tangent to this arc, another line, another arc, another line, and then a larger arc. We go back somewhere here, then an arc to the left, and a small line here. Nice, very nice. Dimensions are in the drawing. You can see this line from here 17, then an arc, another arc, and so on. Look at this drawing and memorize dimensions. Radius here is 15, 16.5, tangent here, then a dimension of 24.5. Here, this point is placed at 55. This one is at 131. This radius is 6.5. This tiny line is 1 millimeter. The point is placed at 38 from the center point. This will be the center point. 38. And the last dimension is 16, this radius. This segment must be constructive. Finish sketch, F6. Next are the sketches for the 4 ellipses plus 1. Remember the dimensions, and we place firstly some planes parallel with XZ and place in this point. Sketch, F5 to see the previous situation. Ellipse, ellipse is so, yes, with dimensions of 7.5 and 10. Look at the semi-axis where I place dimensions. Finish sketch, visibility. Next is a parallel plane with the same here. Sketch, F5. Project geometry. Now I have to project to have the center for the ellipse. You wait to see the vertical mark, yes, then move to draw the ellipse. Dimensions are 3.5 with 10. 3.5 is this semi-axis, 3.5, and 10 is this. Finish sketch, visibility, plane, same parallel to this point. Sketch, F5, project geometry for this, and we have a point now here. Ellipse, vertical and horizontal. Dimensions are 2.5 and 8. This is 8. The two semi-axes. Finish sketch, visibility. The other one is parallel with the same plane through this point. Sketch, F5. Now you know the procedure. Project this line and place the ellipse vertical and horizontal. Dimensions are 2.5 on 6. Good. The last one is placed in another kind of plane. I turn the picture and I place the plane here along this small line with the end here. Sketch, F5, project geometry, ellipse. Now the vertical is this, with dimensions of 3.5 on this direction, on 6 on the other direction. Okay, finish sketch, visibility, F6, and now we apply loft by selecting in succession all these ellipses, 1, 2, 3, 4, 5, and then the directory, which is this. Okay, and we have the main feature of this object. Yes, very interesting. We continue by creating this revolution part, but only external. Dimensions, diameter of 42 and thickness of 20, centered in the center point. This is very easy. We draw a rectangle like this with the center point of the bottom line on the center point of the model. Then we convert this to a center line with diameter of 42 and a thickness of 20. Finish sketch, revolve with join, of course. Okay. And then we apply the hole which is 25. Face, center, 25 is already selected. Good. Then we apply the two fillets, radius 2 and this one. So this is radius 2 by default, and the other two. Good. The part has a hole with a chamfer diameter of 6. We select this plane, we create a sketch, F6, F7, circle of 6, finish sketch, extrude, symmetrical all the way with cut. Okay, then chamfer of 1 and 1. F6. The last is this indexer with dimensions of 5, radius 2 and 60 degrees. To do this, we create a plane, but firstly a sketch to have this point, a plane parallel with XZ through this point. Sketch, X must be to the right, F7, we already have a line, we draw the others. Line from here down, slope, arc, slope, we go to the level of that last point. Let me tell to Inventor which point. Now is okay. Good. Is really okay? Yes, it is. The first thing to do is to make equal these two lines to have a symmetry there. Then dimension of 5. You see these are aligned. Tangency of this arc with this line on the same horizontal, the center with the center, the radius 2 and the angle of 60. This is not okay. Coincident this point with the end point. Now it's fully constrained. Visibility, extrude, this, cut, symmetrical all the way. Okay. There is a sketch which must be not visible, and this is the part, my friends. Let's apply material, our steel cast with the aspect of steel cast, as you can see. Then we select some faces to be machined, all this, and of course the indexer faces, which are machined. Good. Still polished. F6. The data of this part eye properties are here. You see dimension here very well. So if you want to model the part, you have the reference here. But now there is a bonus for you. Be careful and take care with that bonus. Now we wonder how much must be the force to apply at this end of the elastic part of this object. What is the force to bend the indexer and extract it, knowing that this distance is 5 millimeters? To find the answer, you can use finite analysis or stress analysis. Let's do this, but before we have to apply some machining on this face to place there a force. To do this, we create a plane on this face, 0 distance, and a sketch in this plane with a point on the same vertical with the center point, and placed at a distance of say 70. Oh, 70 is almost. Why? To apply hole of 1 millimeter with a depth of also 1 millimeter. The plane is right this, yes, we know this. Good. Then having this hole, okay, we can activate the environment stress analysis, create study, okay with the default settings, and we fix this interior. This is fixed, okay, and we apply a force here with direction of the hole, the other orientation of say 5 kilos. Yes, 50 newtons, or better 5 deca newtons. Yes, 5 deca newtons are almost 5 kilogram force. Okay, a strong worker can apply 5 kilograms, can apply 20 kilograms. This is the normal force in industry, 20 kilograms maximum. Okay, now what? Now we apply the simulation. Run. This is exaggerated. Let's apply actual, and to see the displacement. The displacement is 1.8 millimeters. Oh, we need 5 millimeters. Let's change the value of the force. Double click on the force in loads, and we place 15 decanewton. Again, simulate, run, and now the displacement is 5.3 millimeters, just enough to extract the indexer. You see, this is actual from the channel of the other part. Yes. What is the answer? The answer is yes. We can use this shape of the part to have enough elasticity for making indexing with it. That's all for today. Thanks for watching. Bye bye.